Hello Earth, welcome to episode 46 of season 3 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. So if you're just tuning in for the first time, I recommend you go check out this official page, which is github.com/alt_cell. I'm pasting now the link in the description. So where were we? I was actually writing down some ideas I had, and they were more like I want to say theoretical, so I just basically didn't record this. It's about 20 minutes. Interesting observations that were coming out about making sense of Cell. So they will be there in the repository, of course, which is in this page. These development notes. That's basically now the core of what I'm doing. I mean, the code still comes out, right? And other parts of the README sometimes too, but this is really the day-to-day of it. It's becoming very important to me to have these development notes. They're actually the center of my work right now in Cell. It's a bit old, I need to refresh it. It's taking a while. Because I'm uploading a couple of videos now from the previous 2 episodes. Anyway, it's just loading. It's okay. So let's just look at the face of the Gorgon for a bit again and just take a look at those pipes I was thinking about yesterday. Again, why do we need them? I want to get yesterday's use case. Today I'm particularly fried. Anyway, what was it? Yes, have a hash. I want the hash only has one distinct step value on the first step. I want to get that value. I want to get the rest of the hash, which in this case is also hash. No, the value. Everything to its right. I need to improve this terminology like crazy because it's really hampering me to not have proper terms for this. So, terminology. A hash, a text is a single path with a single step where the value of that single step is a text. Same goes for a number. A list is a list of paths where the first element of all the paths could say a set, do not say a list is a list. For the first element of all the paths. Now, where the value of the first step of each of the paths is a number, and then a hash okay, let's just run it by this fellow just to clarify my ideas. Also, it's like gives me a bit of a pause, get something, it's like a bit of a call and response kind of dun, 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 dun. To shorten, saying as a value we can just say is. So the m step of the end path is x. When we have a list or hash, we say that its elements, we define its elements to be the distinct groups of paths that we can create by separating on the first step of each path. Oh yeah, good typo. For one indexed. Has n elements when its paths have n distinct values on the first step of each of its paths. That's a better definition, I think. Sorry. So the value of a step of a path can only be one text or one number, but the value of prefix a prefix is a path. It's the left part of a hash. It can have a length of 0 up to the path minus 1. The value of a prefix is all the paths that is the sequence of all paths that have that prefix, but with the prefix chopped off each of them. Yes. Yes. Good catch. Three, four, right now, 3 users. Same prefix. I'm trying to do the notation of not notation. I'm trying to define more formally the not mixing of types. Yeah, let's just change this. Yeah, I got it. We start with a hash with only one element. So now we can just talk about elements. We want to get the value of this element. For that, we need to take the original hash and need to do original hash value of the first step of the original hash. Getting the value of the first step of the original hash can be done by obtained by either making the hash into a list of paths, then getting the first step of the first path. Making a values call that gives back a list of values. No, not values, it would be keys. So it would be keys of input and one. Both have the same problem. We want to do or let me see what I did yesterday. Yeah, I was using the comma already for that. Give me a sec. I'm gonna move. But I'm not letting go of this problem, and the terminology is definitely helping me. But I have ruled out parentheses. So what can we do? The solution I was thinking of was to write this input comma 1 right? No, just comma 1 basically, because I need the first one, right? No, it's 1 actually. I was wrong yesterday. Just need to get the first path and then the first element. Input how would it really work with first resolve input then list, or input and then is, then do I've forgotten how good this album is. But here, for example, but how far left can this thing go? say that it only works for the current path. It doesn't go up. So it's really about doing things in on the same line, which it really is. Because this whole thing is to avoid clunky variable assignments. What if I just use parentheses? You wouldn't use them often. But no. Yeah, I'm thinking about parentheses again, and I have a good reason not to do it. More than a reason. But let me finish it. In this case, it would work. But what about here? In this case, I want comma 1 to be an after input lists inputs I want this loop data. It will be, yes, it is why list didn't work. So I start with list input, then I do 1 1 on that. And then I just do input. I don't need parentheses around the outermost add input because that goes right to left. And we're fine. With commas, we could do it like this. Am I gonna get away with this? I wouldn't bet money if I were you, but I cannot bet money with this because I'm just betting my life on this. Well, my life's work at any rate. But you could do something like this. And then, so commas. And solve right to left. We start at the rightmost at and resolve until you hit either the beginning or another comma to your left. Then if there's a comma to your right, you do the reference of what's after that comma and put the value on top of it. Then you keep on doing the same for more commas to the left. Why not parentheses? Because you cannot see the result on top. Do you put it on this or on this one? You could still put it on, but I think this method of the commas is perhaps elegant. Has that unary fourthy quality that comes from natural language. We're getting away with this. This is done. Yes. I think this could work. It could really work. Parentheses would still work, but they are clunky because they are two. If we were to use them, we'd definitely put the result on top of this one. Still, I like the comma better. Wow, it's taking its time. Yeah. Wow. I still cannot believe that much. Maybe, do I have this? Am I logged in here? Apparently I am. Yeah. I wish you could see the amount of tokens that it's processing, like the count. Yeah. Explicit variables are allowed. Why am I looking at the LLM so much if things are right in front of me? Yeah. What's the closest thing you can think of syntactically to this comma? in programming languages. Something like this has to be an analogy, because I don't think there's a direct comparison available here. Interesting. Haskell's delaying function application. That isn't what. Then also delaying function application. No, it's not the sugaring. Is it the sugaring? It's not really the sugaring, because it is all still in a path, on a single path, to be more precise. If you did this with variable assignment, which you can, you would have to pick names. Low precedence in the sense that, yeah, low precedence, yeah, like parentheses. Okay, it's getting late and I need to stop here. Thank you for watching. I'll see you next time.